Hello interwebs, welcome to Let's Fix Computers. I've got a Dell G315 laptop here, which apparently cuts out when the charger is plugged in, or rather the charger cuts out when it is plugged in. This is probably going to be a classic one for Dell laptops. We've seen several of these on the channel before, but I'm struggling for content right now, so by Jove, I'll take an easy win. Also, I've been sick for nearly a week now, and I'm very bored of that. It's not COVID. Tests are still negative, but whatever. Anyway, let's get to it. So I've got my charger plugged in here. You can see we've got a green light on the charger. Green light on the charger. And the moment I plug it in, you'll spot that the light goes out. Bam! And the light is gone. And when I unplug it, it does not come back. So in order to reset it, we need to unplug the charger. And I'll just leave that disconnected for 60 seconds so the charger resets. Some chargers will reset immediately when they are replugged. This is an old one I've got because my other charger is elsewhere and doing other things right now. And while I wait for that, I'm going to start taking the bottom off of this laptop. So this is going to be a short circuit somewhere around the power input. It will be fairly fundamental. The charger is cutting out because of a major power fault. And major power faults are good because they're easy to spot. So yeah, let's get these screws out and we'll see what we can find. I'm expecting a reverse diode to be faulty, or a dead capacitor somewhere in the battery charger circuit. You know, that kind of general vicinity, which can also cause this. Fingers crossed for a TVS diode though. That'd be awesome. I'd be down for that. Okay, I've got a couple of screws here that don't want to come out, and I'm not sure if they're captive or if they're just stuck. Neither would surprise me. Dell have a weird habit of putting some captive screws on the bottom of their laptops. And I don't know why. There's no you either have all of them captive or none of them captive. It makes no sense to just have a couple of them. Anyway, let's get the back cover off of this. Or is... yeah, the back cover is coming off. There we go. Whoop. That's a nice layout. Oh, that battery's toast. Yeah. The battery's getting a little bit spicy. So, I'll be surprised if that's got any life in it at all. Which doesn't matter for this particular fault. We don't really care about that. Okay, let's take a look at the power input area. And so you can see on the back of this connector here, we've got black wires coming in to the ground connections here. Then we've got a white sense wire. And then we've got two reds and we've got two oranges. And are they all common together? I think they might be. Let's just quickly jump into resistance mode and start doing some checks. So firstly, do we have a short across the DC jack? So let's check the blacks to the reds. We do not. That is a few hundred kiloohms and rising. Sorry about the terrible view of the multimeter here. That's not actually a useful view. One sec, let's pull back to there. I've got to sort out my multimeter cam again so we don't have this problem. Let's show that again. There you go. So there's our hundreds of kiloohms across the DC jack. So what of the orange then? What are those? That's the same thing. What about between red and orange? Yep, those are the same. Fair enough. Okay. So in that case, we're not going to have a problem with the TVS diode, which is this guy. So that is reading high in one direction and high in the other direction. No problems there. What's our BIOS battery doing? Because it's right there. That needs to be on voltage. The BIOS battery is at 2.98, which is a touch low. might just lob a different one in there. But let's carry on checking for short circuits first. Okay, let's look closer at the board. So our power comes in at these 4 pins here, and it goes up here into this MOSFET. And then it looks like we're going from this MOSFET into this one, through here, and into this current sense resistor. So this is our inrush limiter and our main current sense resistor. So the output from this bit here forms the start of the main power rail in the laptop. That's where everything starts. So is that shorted to ground? And the answer is yes. The main power rail is shorted at 2.6 ohms. Right. 2.6 ohms is not a dead short, but that's extremely low. So there's the beginning of our problem. Alright, so we have a shorted power rail. Okay, it's time to take the board out. Let us strip this laptop. Spicy pillow. Disconnect all wires. Ooh. Watch me forget to plug this back in when I put the motherboard back in. Right, the board has been removed and stripped. Let's inspect it for things that have exploded. So I'm looking along VCore down here for, you know, anything that's melted, darkened, that kind of thing. Not seeing anything obvious, although things don't always look broken. GPU VCore. I mean, they're all slightly different colours. Doesn't really tell me a lot if I'm honest. There's no craters in the board though, which is the first thing I'm looking for. Right, so we are past visual inspection. So the next thing we need to do is we need to have another look at the short circuit, and we need to determine if that short circuit is likely to be through a faulty component or whether it's going through one of these power stages, like one of the CPU power stages or one of the GPU power stages, into one of the PUs, one of the big BGA chips. We can't just inject voltage yet. So this is a super important part. So let us go back into resistance mode. And what we want to do is we want to find a more definitive detection of that short circuit. So once again, we originally saw it up here on the current sense resistor, where it's still sitting there at, you know, 2.5 ohms. I'd like it to be lower than that. Let's check it. We should find, here's a nice big input capacitor. That should be there as well. Yeah, 2.8. Okay. What I'm going to do now is I'm going to check the back of these inductors that are going into the processing chips. And I'm going to see if either of those read the same value. Yeah, they do. 2.7. That's not a good sign. What about these ones up here? That one's 1.44. Right, so the GPU ones are even lower. Now this is normal because the CPU is low resistance, the GPU is really low resistance. Now the fact that the GPU is even lower than our apparent short circuit means that these guys are probably all fine, so not worried about the GPU. But the CPU inductors being at the same resistance as our apparent short means there's a very high likelihood that one of these guys has gone. And if we go from this capacitor to the back of one of these VRMs, we get basically 0. So we have a direct short through one of these VRMs into the CPU. That's bad because that means that the CPU has seen 19.5 volts. So now it's a question of, has it survived that? Hopefully, fingers crossed, the powers that be in this laptop, a la the power management, has detected the fault quick enough to avoid damage to the CPU. But we can't inject power on this, because if we inject power into the main power rail, it's going to go straight into the CPU. So we need to figure out which one of these has gone bang. Right, I've just cleaned off the chips while I was talking on the phone, just so I don't put my finger in the thermal paste. Where was I? Okay, so we need to determine which one of these guys is our culprit. So firstly, I'm going to do another visual inspection and look real close at those. See if I can see any signs as to who our culprit might be. Can't see any signs there. Right, in that case, what I'm going to try and do is lift these inductors. So I'm going to do this with a soldering iron. You can hot air inductors clean off the board, but I have recently heard that it's entirely legitimate to just use a soldering iron just to lift one side of an inductor up to find out what side a short circuit is on. So what we can do now is I can lift these up one by one until the short circuit vanishes, and that will let us know which one is the culprit. And then we'll leave that one disconnected and see if the system comes good. I don't think it will, to be honest. I think we're probably dead in the water because the CPU has seen 19.5 volts. And that kills the CPU, but you never know. Sometimes you get lucky. Sometimes the power cutouts hit really fast. It's easy to forget that stuff in a computer happens really quick. Right, putting some solder flux down there. And of course the flux doesn't want to flow because it never does for me these days. And these are very heavy power planes, so it will resist. And I've not tried this method of lifting one side of a inductor before. Oh, there it goes. There we go. That guy is now disconnected. So, is it door number 1? No. Is it door number 2? No. Our resistance is steadily getting lower. I don't know what that means. Is it door number 3? Yes! Behold, we now have high resistance on the main power rail. And our CPU is still low resistance because it is. The CPU is low resistance because it is a low resistance path to ground. But the main power rail is no longer shorted. Right, so it was this guy. So what I'm going to do, the first thing I'm going to do is solder these guys back down and confirm that theory. Those are probably flat. We are still no longer shorted. The multimeter is dancing around a lot because there's a lot of capacitance on this rail, which is giving the multimeter a very hard time in getting a solid read. The important thing is that it's not immediately going at me. So I'll check the current sense resistor again. And again, we're seeing that start auto-ranging into high ranges again. So the short has disappeared. So this power stage has probably gone bang and gone short circuit. Our CPU is probably dead. But let's see if we have any luck. Let's see if it turns on. The worst thing that can happen is that it doesn't turn on right now. I can't put the CPU cooler on with this inductor hanging off. So I'm going to take the inductor off altogether because then I can actually put the heatsink on. It's not super important just for a test run, but also it's really easy to just remove the other side of this inductor. Okay, that should be enough for us to get a post. And let's see what we get. So I'll plug the charger in. The charger light has stayed on. And let's risk the power button. I push the power button. Nothing appears to have happened. I keep thinking I can hear a ticking coming from it now and then, but I think that's just stuff settling. Don't like that noise I'm hearing. It sounds very odd. Right, no, we're not really getting anywhere here. That ticking really sounds like it's coming from the V-core area. I think it's that particular power stage with no inductor on it making noises. It may well be that it really doesn't like not having an inductor on the output. I think I'm going to take that power stage off altogether. Right. Hot air activates. We're taking the power stage off. Flux. Hopefully some of that flux has gone under the chip. With that power stage removed, can we glean any additional information at this point? Such as whereabouts it is shorted to. We don't know the pin out of this thing yet, so we're going to sort of take a couple of stabs in the dark here and figure it out. So this part is the actual ground pad of the power stage, because these pins all connect to this center pad, and they're connected onto the ground side of these input capacitors. I think that's the main power input for it. This could be an additional ground, but I'm not sure. And I think these pins here and here are all outputs onto the inductor. This is not shorted, so it is definitely a fault within the power stage and not the motherboard itself. Which is a good sign, because it means if the CPU is not dead, we don't have to dig out a short circuit or anything like that. So, okay. I think we'll have to power it up again, or try and power it up again, to see if we've actually achieved anything this time. I suspect that it was failing to power up that time because there was still a shorted power stage on the main power rail. Okay, I'm going to get this thing reassembled again. Motherboard back in the laptop. Let's find out if we've achieved anything. So I'm kind of hoping for a power up this time. And basically what we want to know is the CPU brain dead or not? That's all I care about knowing, because if the CPU is dead, then we're done. Alright, I plugged it in. The keyboard backlight flashed just then. We've got a light on the charger. And I'm going to push the power button. No reaction. And the charger light went out. Okay. I'm going to tilt it over so we can see the back a bit more. Let's turn this around because the charger is super unstable. And I'm going to listen out and see if I can hear that weird ticking again. Because if I can't hear that ticking, then that pretty much confirms that it was probably that power stage that was making the noise. Which I'm fairly certain it was. Right, charger light again. Here we go. Oh, the charger light has gone out on its own. Okay, don't know what that means. Okay, when I press the power button, the charger light turns on and off. Fine. Is the main power rail actually up at the moment? I'm 99% certain this CPU has had it. I'm certainly not going to go and buy another power stage to find out. What I was kind of hoping to get is just that it would light up and we'd get fan spin, just no post. And at that point, it would be fairly reasonable to be like, okay, the CPU is dead, goodbye. But this is a little bit inconclusive, and I'd like something a little bit more telling than this. I shall measure the main power rail from the current sense resistor. Yeah, that's up. Yeah, we don't know if it can actually run with one of those power stages missing. Or if it can even turn on. Or it might just go, no, we can't do that because there's a chunk of the motherboard missing. I have seen laptops run with like half of the CPU and V-core phases pulled off the board. But those were not smart power those were not power stages. Those were just discrete MOSFETs. So, I don't know. I'm going to try this one more time just for posterity, but I think we're done here. I'm holding down the power button. No, this thing is dead. That's unfortunate. Okay, well, what I'm going to do, I will put the inductor back on just to complete that part. There's no point in putting this power stage back on because it's dead. And that is where we're going to have to wrap this one up. So this video is an interesting example of what happens when you're short on a main power rail is not an easy one. because usually as soon as I see a short circuit on the main power rail, I'm like, good, those are usually the easy ones, because that probably means you've got a bad capacitor somewhere, or it's a bad TVS diode, or what I was hoping for in this video. But this is an example that it's not always that simple in this case, and this is the other reason why I really hate working on gaming laptops, because when it's a gaming laptop, it's never simple. I mean, it is sometimes, but on a gaming laptop, there's a very high likelihood that a VRM has gone bang somewhere and sent main charger voltage into your CPU or your GPU. And that's exactly what's happened here. That CPU is dead, I'm calling it, and that's the end of it. I hope you guys found that interesting. It was a good example on how to demonstrate a failed VRM. If it had switched on, and if we'd possibly even gotten post out of it, what I would have done was jumped on eBay or AliExpress and ordered another one of these power stages, and we would have been able to complete that broken VRM. That would have been how I'd progress from there. But in this instance, we've every reason to believe that the CPU is dead at this point. So I'm not going to bother going any further with this, because it's going to be a lot of time and effort for what will probably still be a dead CPU. All right, thanks for tuning in, everyone. I will see you in the next video. Bye for now.